You're falling through Venus's atmosphere right now. At 50 kilometers above the surface, sulfuric acid clouds are dissolving your lungs at 2 millimeters per minute. Temperature sits at 200 degrees Celsius, hot enough to cook your corneas, in 15 seconds. Pressure is 1 bar, same as sea level on Earth, but you can't breathe because the atmosphere is 96% carbon dioxide. Most people think heat kills you first on Venus. They're wrong. You'll die 6 different ways before you hit the ground, and the order will surprise you. Let's start at the top. You drop into Venus's upper atmosphere, around 65 kilometers up. Temperature is mild, 75 degrees Celsius, manageable for a few minutes if you're protected. Pressure is low, about half of Earth's sea level. The air is thick carbon dioxide, unbreathable but not immediately lethal. You're falling fast, picking up speed. At this altitude, you'd pass out from hypoxia in 90 seconds. But that's slow compared to what's coming. The real countdown starts at 50 kilometers. You hit the sulfuric acid cloud layer. These aren't water clouds. They're droplets of concentrated acid, suspended in superheated gas. The acid contacts your skin and starts breaking down tissue. Immediately. Your eyes go first. Corneas clouding over as proteins denature, from heat and chemical burns simultaneously. You're inhaling acid vapor now, and it's eating through your trachea, dissolving the lining of your lungs at 2 millimeters per minute. Temperature has jumped to 200 degrees Celsius. That's above the boiling point of water, so any moisture in your respiratory system is turning to steam, scalding you from the inside. Pressure is still only 1 atmosphere, barely noticeable, but you're already dying from respiratory failure and thermal damage. Time to death at this altitude, 3 to 4 minutes from lung destruction. You keep falling. At 40 kilometers, pressure climbs to 4 atmospheres. That's the equivalent of diving 30 meters underwater, but instead of cold ocean, you're surrounded by 300-degree gas. Your lungs are collapsing inward now, chest cavity compressing as external pressure overwhelms your ribcage. Blood vessels in your lungs are rupturing. Pulmonary barotrauma. You're coughing blood, mixed with dissolved tissue. Temperature is high enough to melt lead. Your skin is blistering, subcutaneous fat liquefying under the heat. Carbon dioxide concentration is so extreme that even if you could breathe, you'd die from hypercapnia, CO2 poisoning, that acidifies your blood and shuts down your brain in under 90 seconds. You're 40 kilometers from the surface, and your body is already shutting down from 3 simultaneous failures: pressure, heat, chemical burns. At 30 kilometers, pressure hits 10 atmospheres. Your ribcage is being crushed inward, with the force of a car sitting on your chest. Temperature is now 350 degrees Celsius, hot enough to ignite paper, to melt zinc. But here's where it gets worse. At 10 atmospheres of pressure, nitrogen dissolved in your bloodstream starts causing nitrogen narcosis. You're hallucinating now, losing motor control. Thoughts scrambling as your brain floods with confusion. Divers call this rapture of the deep. On Venus, it's rapture of the descent. You can't think clearly anymore. You don't even understand you're dying. Time to unconsciousness from narcosis. 60 to 90 seconds at this pressure. You're still falling. At 20 kilometers above the surface, pressure reaches 20 atmospheres. You black out completely. Nitrogen narcosis shuts your brain down. Before heat or pressure finishes the job, you're unconscious, body limp, tumbling through 430-degree air. Your tissues are cooking, bones starting to char. But you're not aware of it anymore. This is the mercy point. You stop experiencing your own destruction. And you still have 20 kilometers left to fall. At 10 kilometers up, pressure is 50 atmospheres. Temperature is 450 degrees Celsius. Your body is a burning, collapsing mass of carbonized tissue. The remaining moisture in your cells is boiling away, skin blackening like overcooked meat. At 5 kilometers, pressure is 70 atmospheres. Your skeleton is fracturing under the load. Bone marrow is vaporizing. At 1 kilometer, you're unrecognizable, organic matter compressing into a dense, scorched lump. Then you hit the surface. Pressure, 92 atmospheres, equivalent to 900 meters underwater. Temperature, 465 degrees Celsius, hot enough to melt lead, zinc, and tin simultaneously. But you've been dead for 40 kilometers. Your body impacts the ground as a crushed, incinerated, chemically dissolved fragment that used to be human. The surface doesn't kill you. The descent does, layer by layer, mechanism by mechanism, in an order that defies expectation. Heat is the slowest killer. Pressure and chemistry are faster. But narcosis, the thing nobody talks about, is what actually ends your consciousness first. Venus doesn't give you one death. It gives you 6 stacked on top of each other, happening faster than your body can respond. What should we investigate next? Comment your most disturbing planetary death scenario, and subscribe for weekly deep dives into the science that kills you in space.